The next question deals with higher order polynomials. So a polynomial is of the form f of x equals an, which would be a coefficient, x to the n plus an minus 1, x to the n minus 1, all the way to some value a0, where n is a whole number. So each of these problems, 83 to 87, will fall into this form. So we need to determine the degree of the polynomial, and let's just take a look at the first one. First of all, we have some squares and cubics. If we have a function, so if the order of polynomial is odd for n greater than or equal to 3, say, then it looks like this. Polynomial is going to be looking something like a cubic. There could be any number of these little bows, but in general, your end behavior starts at negative infinity and goes to positive infinity for the y-axis. And polynomials don't have any problems with domain. The domain for any polynomial should be all real numbers, and it will be all real numbers. Let's see, and if it's even, let me scroll down a little bit. For n even, and we're going to look more something like this. Some sort of parabola looking thing, or it could look like this, where we have some I'm trying to draw there, and I've all right, let's try that again. Let's try black this time. Let's see. It could look something like this, some sort of W shape, or many of these little pits and valleys, as it will. So that's what we're going to have when it's even. So let's go back up here and take a look at, or I guess we can just do this number 87. So let's do number 87. We're being asked, find the degree. So the degree is the highest number as an exponent. So the degree here is 3. Which means that it's odd. It's an odd number. Find the zeros. Okay, so find the zeros, if any, find the y-intercepts. Okay, so find the zeros. So basically what we do is we set this equal to 0. So find zeros. So we set 3x minus x cubed equal to 0. And then we solve. So we're going to do the same process with the fundamental theorem of algebra. We're going to factor out the x. We have 3 minus x squared equals 0. So if either the x or the 3 minus x squared is 0, the entire function will equal 0. So clearly we have a 0 when x is 0. That will work. And then we need, for this part here, x squared, 3 minus x squared has to equal 0, so x squared needs to equal 3, which means x equals plus or minus root 3. Those are our possible zeros. We're looking for the y-intercept. For the y-intercept, we plug in the function at 0. So this is going to be f at 0, which is equal to 3 times 0 minus 0 cubed, which is just 0. And we knew that already. We had x equaling 0 giving us 0 as well. So that's going to be the y-intercept. The end behavior based upon the coefficients, well, I'm going to rewrite this. So we have negative x cubed plus 3x equals 0. This is equivalent to what we have up here. Well, the leading coefficient is negative 1. And this means that instead of it going from left to right up negative infinity to positive infinity, it's going to be the reverse. So instead, our end behavior is going to look more like this. And again, clearly this is a bad map, a bad graph, since the intercept should be at 0, but hopefully you get the idea. So the end behavior will be decreasing. The function will be decreasing, and this cubic will be decreasing.